Okay, last video on section 18.5, and now we're going to return to buoyancy. And just if you want to recap, go and check out the videos on 18.2 and go read that section. So remember that any object that is in a fluid, there is an upward buoyancy force acting on that object. I'm not going to go into the whole derivation of that. You need to go back and check out 18.2. And then there's a downward gravitational force. Okay, so there's an upward buoyancy force and a downward gravitational force. And the basic idea is that the upward buoyancy force is equal to the weight, right, the mg of what? Of the displaced volume of fluid, right? So it's equal to, so an object gets placed in the water, any object, any density, and it displaces a certain amount of this fluid, and now that amount of displaced fluid, you calculate the weight of that fluid, and that's what the buoyancy force is, and it's acting up. Okay, so it's equal to the density of the surrounding fluid, okay, the volume of the displaced fluid multiplied by gravity. That's what your buoyancy force is, and it's acting up, okay, obviously. And then the downward force is the force of gravity. Okay, now the question is, how do we know when this object will float, whether it will sink, whether it will move up, down, right? Okay, so let us assume that the upward buoyancy force and the downward gravitational force, let's assume that these two guys are equal. Okay? So that means that the buoyancy force, FB, equals the downward gravitational force, mg. Okay? So on the left hand side we've got the buoyancy force, density of the fluid, volume, the displaced volume multiplied by g, equals mg. This mg is this downward gravitational force. But what is m over here? Remember, this mass is the mass of the actual object, whereas on the left we have the weight of the displaced fluid, but on the right we have the weight of the actual object, the gravity acting on the actual object. Now this mass over here is the density of the object, and we use the average density of the object here, the volume of the object multiplied by gravity. So as you can see, if this upward force and this downward force are in balance, then this guy is basically floating. Okay, does that make sense? When these two are balanced, this object is floating. Okay, so if we equate these two, so we have density of the fluid, the volume, the displaced volume, multiplied by g. As you can see, g cancels out here, equals the density of the object, average density of the object, multiplied by the volume of the object. Okay? So this is basically when the object is floating. This is when the object is floating. It makes sense, right? Because the upward buoyancy force balances out this gravitational force. Okay? Now let's look at this. Let's look at this equation over here. All we've done over here is rearranged the terms. So we've got the displaced volume equals the ratio of the density of the object to the density of the fluid, multiplied by the object's volume. So the displaced volume is the density of the object divided by the density of the fluid multiplied by the volume of the object. Okay? Now, look at this. Look at this. When would this object float? When would this object float? Well, if this object floats and there's the water and then the object is not fully submerged, but there's a portion that's submerged and the rest is above, then we can say that the displaced volume, that's the displaced volume there, is going to be less than the volume of the object. So if we rearrange this, we could say, if we divide that by that side, the displaced volume divided by the object volume, okay, this will be smaller than 1, this will be smaller than 1, so that tells us that the density of the object will be less than the density of the fluid. So an object floats when the density of the fluid is greater than the density of the object. The density of the object is less than the density of the fluid. Okay? But there's another case. There's another case that they don't mention here, which I want to bring to your attention. If you recall, earlier in that section on 18.2, we said that so long as the upward buoyancy force equals the downward gravitational force, then the object can float. And we saw that a ship's hull, right, made of steel, right, which the density of the steel is much higher than the density of water. So how does this still float? It is because the displaced volume is equal to this ratio. So if the object is steel and the fluid is water, say, then this over here will be much greater than 1, and we multiply that by the volume of the actual object. That's the volume of the object. So the displaced the displaced fluid is much greater than the volume of the displaced fluid is much greater than the volume of the object. And then you will also have the object floating. Okay? So make sure that you absorb those two ideas.